When I was a bachelor student, I worked extra in home care, where I met several patients suffering from chronic wounds. One woman that I especially remember struggled from a wound that needed care several times a week. One wound had gotten so badly infected that she eventually had to amputate a part of her leg. For her, these wounds did not only impose physical pain and trauma from losing a part of her body, but also affected her independence and social life. What if we could help the body heal before a wound becomes chronic? In our group, we study how electric fields can help guide cells to close wounds faster. By applying direct current stimulation, we have seen cells move towards the wound sites, speeding up healing by up to 3 times compared to unstimulated controls. This could mean fewer chronic wounds, less suffering, and reduced healthcare costs. Our first results were used with metal-based electrodes, while the second generations were made from carbonized polymers. But to make this solution sustainable, we need to move away from using scarce metals and fossil-based materials and start using materials that are renewable and grow in abundance on our planet. My project explores wood-based electrodes as a renewable, cost-effective, and biocompatible option for wound stimulation. At the core of my project is using cellulose and lignin as a carbon source for laser-induced graphene electrodes. Cellulose provides a mechanical strength, and lignin's aromatic structure is ideal for forming conductive carbon. By locally heating the material using a laser, we can make the carbon atoms rearrange into conductive graphene. This is a straightforward technique that lets us design flexible electrodes directly on the film substrate. This is perfect for single-use wound dressings without relying on scarce resources. To ensure clinical relevance, we aim to test our electrodes on 3D bioprinted wound models. This would allow us to expand on our previous monoculture studies and track cell migration in 3 dimensions. This is key to showing the relevance of wood-based electrodes in bioelectric stimulation. So, with wood-based electrodes, we aim to make wound care more sustainable and help prevent suffering and loss for patients like the woman that I met. Thank you.